So today, down to the bottom of the first page of notes, we're going to start here. Date things, people. So we start at the bottom with some definition stuff, which we're gonna add a little bit to this, so we make sure we know what this stuff means as we get into doing some of the problems. So we're going to chat today about what's called domain and range, another fancy math term, okay? A listing of your x values. We're going to add a little bit to this. From least to greatest. So when I'm listing my domain values, okay, if there's a bunch of numbers there, I put them in numerical order. I go from the smallest number, which could be a negative, to the biggest numbers, which could be positive, but it's at least going to be bigger as we go. And we'll chat about some easy ways to do that as we're doing it. But again, remember, domain is the x values. Now, range. Same idea, except it's the y values. From least to greatest. So when we're thinking about y, that can be on a graph. That can just be numbers that are listed. Okay? But as long as I keep the x and y parts straight, I should be in pretty good shape on things as far as that goes. Now, the last thing we're going to be focused in on today is whether something is a function or not. Now, we started with functions yesterday, that f of x thing. How do we know if something is a function? Okay, this may not make sense until we get into a physical example here. Every x only goes to one y. You're like, okay, what in the heck does that mean? So let's do an example here. So let's say I've got a little chart with some numbers here. I made this up. There's not something else I'm referencing to. And so if I have this chart, when you have a chart, the x and the y values go together. So like here, 0 goes with 2. 1 goes with 3. 2 goes with 4. And 3 goes with 5. Notice each x goes to one y value, and there's no x's that repeat. So visually, this ends up being what's called a function. I put one value in, I get one value out. It's kind of like a machine that makes things. However, if you get into a situation where you have an x value that goes to more than one y value. X is 1, y is 3. X is 1, y is 4. You're like, wait a minute, how do you do that? X is trying to go to two different y values. That doesn't work. And so the ones, the x's repeat. So if you ever see an x value repeat, that's not a function. And we're going to visually see a way of doing that too here shortly. But that's really the only trick you need to know. If all the x's are different, it's a function. If any x's repeat, it's not. That's really the only rule we need to know there. And then we're going to have tables of values that kind of let us see. So these would be two good examples of a table of values. Okay? I can use them to plot points. I can use them to figure out function or not. There's a lot of things I can do with those. But as long as I remember this part, the rest of it's going to take care of itself. Now, let's actually put this to use. We might have to flip back and forth a little bit. So as we flip over to page 2, we're going to do a couple of examples of how I can figure this out. So my first job is we're going to make ourselves a table here, an XY table. And if it's been a little while, when you're looking at a coordinate point, the first value is the x, and the second value is the y. So we're going to take those 4 points up here, and we're going to put the x and the y values. So we're going to do that all the way down here. Okay, again, if you ever need colors, I still got colors on the back table. And so I'm going to list those in this chart. And so once I do, okay, reminder again, the domain is just a listing of the x values. Now, here's how this works, how we write it. We're not just going to write 2, 3, 4, 5. We're going to use this little symbol, this little squiggly line thing. It's called a brace. And what I always tell people when you're drawing, it is like a scribble, but if you really look at it, it looks like the silhouette of a person. You got a person with a really big forehead, a pointy nose, and a pointy chin, okay? That's all a brace is, and then we're going to list off the x values from least to greatest. So we're not using parentheses, we're not using brackets, we're using this little scribble. And then we're going to do the same thing with our y values. Again, always looking to go from least to greatest.
So if you don't use the brace, is it wrong?
It's partially wrong, because if in math, the braces are what's called set notation. This is me saying, okay, this is every x value I have is these. Every y value I have is these. That's what the braces tell me. And so the question on is it a function? Yes it is. Okay, why is that again? Because all of the x values are different. We don't have 2 y values for one x. But again, our focus is right here. That's why I can tell you that this is a function. Okay? So, you're like, really? This isn't bad. There's not a whole lot of math to it. It's just a quick recognition. We look, and then we go from there. So if I do that again on the next one, what I'm going to do here is I'm going to freeze frame this. Well, at least for those of us that are live here. I'm going to freeze frame this. Use this first one to try and make your table and write some of the things with your domain and range. And then let's see if we've got this down or not. So there might be one twist in here for us, but we'll make sure that we chat about that too. When the people watching this later have paused their video so they can have tried this out some as they're working. What's that? I do. I will tell people to pause, but sometimes they do, sometimes they don't. I'm never going to know. So, okay, I'm going to unfreeze. So, a couple of things to take note of here. And if you're still working, that's fine. So I make my chart, making my x's, making my y's, because again, I'm kind of just following this along. So when I go to write my domain for this one, if numbers repeat, like the 1 does, I do not have to write them multiple times. So I don't have to put 1, 1, 2, 3. Is it wrong if I do? Not exactly, but we don't need to do it. And then the range, they're all different, so I go ahead and I write all my y's. But when it comes to the question then of if it's a function, this time the answer is no, because you have an x value here that repeats. The x value of 1 has two different y values. One goes to 4 and one goes to 5. That's not going to work with these. So anytime an x value repeats, it's not a function. It's as simple as that. And we do that. So that's how, if I'm given a list of numbers or a chart like this, how I figure out if it's a function or not. Sometimes, though, you're not going to have a list of numbers. You're not going to have a chart. Instead, you're just going to be given a graph to try and figure it out. So here's how we're going to do this. Move this up a little bit here so we can fit. How to determine if a graphed relation is a function. Okay. If and only if there is no vertical line, this is a vertical line up and down, that goes through more than one point. So I actually do this. I use my Post-it notes for this. What you're doing is you're working through your graph from left to right, making sure that any time that you stop, you're only going through one point on your graph. So there I stopped, it was just there. And I go a little further, it's just there. I go a little further. Every time I'm stopping, I can only put my pen on one spot that I see. And if I make it all the way through that way, it's a function. But if I start doing that, and at some point, as I go through, I run into a spot and I'm like, oh, that there's more than one. I sent a smart test too, but just in case, thank you. That it goes through more than one place, like 3 places. That's no. So basically, whether it's a graph where there's lines and everything's connected and plotted, or it's just individual dots, the same idea works. So here I'm going through and I'm like, 1 dot, 1 dot, 1 dot, 1 dot. I'm good.
Can we put it in the lines? Can we connect it?
Oh, I wouldn't. No, don't connect points. Leave the points be, because it's actually probably going to make it trickier at times, because the question was, for those of you who might not be like, is it okay if I like connect the points here? I wouldn't, because let's say somebody decides they're going to connect the points and they go, or they do it in some funky way when they're connecting the dots that it turns it into not a function. So I would absolutely make sure that I leave those dots alone, because it's going to be obvious. If you get to a spot, 1, 2 dots on the same vertical line, bad. No. No bueno. Yeah, no bueno. So that's how we do it when we're doing the visual portion of things and trying to do that. Okay? So as we usually do, I want to jump into the practice, make sure we kind of do a little more, make sure we're good. But don't put the notes away. Keep it handy. We might have to refer back here momentarily to some of the stuff that we're doing. Probably I'll have to anyway. So, okay. Into the packet we go. Practice. Pages 3 and 4 on the 19th. So I look and it says, okay, use the vertical line test to determine if each graph represents a function. What we just did, literally what we just did, is what I'm going to use to do that. So, I mean, your vertical line, again, if you want, you can come from me and get a Post-it note. You can use the side of a folder, whatever it is. And as long as you're going through, it only goes through 1 point. It's yes. If it goes through more than 1 point, then it's going to be no. So I want to be cautious of that. When we get down to the second part, that's what we did in the first part of the notes. Exactly the same thing. Oops, flip back over here. I went too far. Now, here's the thing that changes, though. You're like, okay, I got points. I'm making a chart. Yep. I'm doing domain and range. Yep. Okay, is it a function or not? I can do that. But now, wait a minute. You've got a graph over here. So let's play with number 5. Reminder. When you're graphing, the x-axis is here. The y-axis is going this way. So when I'm plotting my points, that's not two separate things. That's one point. So x, I go to -5. No dot yet. Y, I go down to -2. And I put my dot right there. X and Y. X up to Y. Put my dot. X, Y, put my dot. X, Y, put my dot. So I'm just graphically doing what I'm given there. Once I have that set, I absolutely can go back and make my chart. Put all my x values in here. Put all my y values, all the second numbers, over here to the right. But when I get to domain and range, and we haven't had to talk about this since we put in our definition before. Least to greatest. Don't just list them the way you see them. Okay, we're going to work on the smallest value, or the most negative. And then that's the most negative next. And then 3, I don't have to write it twice, but that's my largest value. That's what I want to end with for my domain. What's that? Technically, it's not right. I mean, I'm not going to jump up and down and scream if you write it twice, but yeah, technically we should be leaving it just once. And then range, again, is my y's. Look for the smallest. Well, I only have one negative, so that's going to be the smallest. Then the next biggest number is 3. Next biggest is 4. Next biggest is 5. But here's the ultimate question. Is this a function? Nope. Because, okay, there's two different ways you could look at it. You could say that the x value repeats. Okay, I see 3's there twice. That would be one reason that it's bad. It doesn't work. The other one would be if I happen to go through on my vertical line test, it fails the vertical line test because I can draw a vertical line through there where it goes through more than one point. Either of those would be a terrific explanation of why that's not a function. So again, we're just kind of getting some of the basics right now. So as we get into some deeper stuff later and start working on some applications and things like that, that it's not going to be too bad. Okay? So you know how I operate. I mean, at least you should at this point. You know when I flip the page, we're going to see something from the past because that's just what we do. So you're like, nope, not yet, Artie. That is still current stuff. You're right. But I come down here a little further. and I look, and I'm going to make mention of one of them because we did something similar to the other ones yesterday. Number 10, quick discussion. Notice I put parentheses on that because there wasn't. Whenever we see a plus or minus with something like that, parentheses is a good idea every time. But here, I need the parentheses because if I don't distribute, if I don't distribute, that's going to be a problem. I'm not going to get the right answer. So I'm getting you started on that one, but I'm not going any further because I'm hoping we can distribute and do a two-step equation. I think you can. I have confidence in you. So as I normally say, do some of the practice, especially the stuff we just learned, so we can get that reinforced and have you ready and raring to go and continue a little bit further tomorrow when we take a peek at our first version of slope. We will get into that then.